Good afternoon. My name is Carlos Romero. I'm a scientist at the College of Vet Medicine, University of Florida. I specialize on animal viruses. I hold a doctorate in animal virology from Michigan State University, and I've done some extensive work as well over the last 25 years on viruses of sheep, cattle, and swine. Well, today I would like to touch on some of the most important poultry diseases that affect the poultry industries all over the world. And I'd like to get started by showing you what might be a typical environment for broilers, for meat-type chickens, houses where it is not unusual to have at least an excess of 50,000 broilers or chickens per house. So the first disease that I like to cover is referred to as salmonellosis, and it is mainly caused by several species of salmonella bacteria. You might as well know that there are more than 2,000 species of salmonella known, of which perhaps about 20 or a bit less are known to cause disease in poultry. Of these, mainly Salmonella pullorum, because of pullorum disease, and Salmonella gallinarum, because of fowl typhoid, are perhaps the most important from the poultry industry view. Now, from the public health, there are other Salmonella that acquire significance, and of these Salmonella, perhaps Salmonella enteritidis and Salmonella typhimurium are the most significant ones. Pullorum disease is basically a disease of young chicks, and one of the main clinical signs that you see early in the disease is this watery white diarrhea, as you see exemplified on this slide. When you necropsy birds that are Salmonella affected, Salmonella pullorum affected, you will see caseous looking or white looking nodules that are disseminated in some of the viscera, in this case the lungs. Also in here you will see white nodules that correspond to areas where the bacteria had multiplied. It also attacks the gastrointestinal tract, and you may see here foci of the disease in the intestinal tract. Also localized in the hocks, the joints of the hocks, and you see this as swelling of these two areas, and you can isolate Salmonella from these spots. They also find caseous or purulent nodules or plaques in the respiratory tract, and in this particular case you will see that this white caseous material has invaded the trachea, and of course this causes tremendous difficulties when it comes to breathing, and some of these animals actually choke themselves to death. Salmonella also attacks the reproductive tract, and this is seen of this slide as very small follicles, or ova in this case actually, that have failed to, or are failing to develop, and you also see that there is a certain amount of hyperemia or over irrigation of the tissue due to inflammation. Now, in the case of both Salmonella pullorum and gallinarum, there is transovarian transmission of the bacteria. This means that the female, the hen, passes the Salmonella microorganism through the egg to the newly hatched chick. And then once chickens are hatched, infected with Salmonella, there is ample opportunities for horizontal spread, both in the hatchery and also when the chicks are put in the houses, in the chicken houses. Now, it is fairly well known that birds infected with salmonella become carriers, and they could become carriers for life. The bacteria is shed in the feces, and of course, this results in a tremendous environmental contamination, and if eggs are in the hatchery are in contact with fecal material from newly hatched chicks, the bacteria can actually penetrate through the egg shell. As I said before, this is a disease of young chicks. The mortality usually occurs very, very early in life, and it could approach 100% when the salmonella involved, the species of salmonella involved, is of high pathogenicity. Now, this is contrasted with fowl typhoid caused by Salmonella gallinarum, where the mortality is usually extended over several months. Now, in the case of paratyphoid, the mortality is much lower. The way to diagnose salmonellosis is by doing bacterial cultures of the affected tissues, and then by typing the microorganism, and you do this by serology, obviously. There are plate agglutination tests for both Salmonella pullorum and gallinarum, and in the case of Salmonella pullorum, you may actually use the stained antigen to detect animals infected or birds infected with Salmonella. In this specific case, the stained antigen, Salmonella pullorum, has been reacted with chicken serum that contains antibodies to Salmonella pullorum, and you see that the antigen has been clumped, or as we say, agglutinated, and this is indicative of Salmonella infection as the or a carrier state, as the animals do carry antibodies for the bacteria. Now, how do we control salmonellosis? I think we ought to start by only purchasing or only acquiring birds for any purpose from breeders and multipliers that are participating in the eradication program for salmonellosis, something which is called the National Poultry Improvement Plan. These birds are already salmonella free, so this is the best guarantee that you have that you will not be introducing the microorganism into your premises. Now, before receiving young birds, your premises should be very thoroughly fumigated. Needless to say, the hatches have to be very thoroughly fumigated before eggs are set for hatching. Another bacterial infection that I would quickly like to cover today is avian tuberculosis. Avian tuberculosis is caused by Mycobacterium avium. You may refer to Mycobacterium avium as a species related to Mycobacterium bovis that causes tuberculosis in cattle, or Mycobacterium tuberculosis in humans. Now, the bacteria causes a chronic infection, and mainly is seen in adult birds, as it has a fairly long or protracted incubation period before clinical signs and lesions are observed. The Mycobacterium is eliminated in the feces, and infection of susceptible birds is usually acquired through the oral route. Now, as infection progresses, there is a chronic wasting. Animals have difficulties putting on weight, in spite of the fact that they are eating well. Some of the signs observed are recurrent diarrhea and lameness, difficulties in translocating themselves from one place to another within the poultry house. So, as I said, when you necropsy some of these birds, you will see that the carcass it's emaciated, it's devoid in meat, in muscle, and as you will see soon, the most significant lesions that one finds are related to miliary or nodular lesions in some of the viscera, mainly the liver, the spleen, and the bone marrow. Now, Mycobacterium avium could also be demonstrated in the tissues of affected animals after necropsy and after making smears on a glass slide and staining the glass slide with acid-fast stains. Now, the organism can also be cultured from the feces, but you do understand the microorganisms grow very slowly, and the growth is usually measured in days, if not weeks. Another way of testing whether birds in a flock are infected with mycobacterium is by performing the tuberculin testing the same way we do it in cattle and humans. And as you see on this slide, we have a liver and a spleen that show a miliary of very minute lesions, referred to as miliary lesions, or miliary tumors, miliary lesions in this case, and much larger nodular lesions that correspond to where the microorganism is multiplied and is being restricted by the chicken immune system, without much success in that case, of course. This is another case where the caseous tuberculous material was found around the neck area. The skin has been folded back so that one can see this white lesion here that corresponds to the tuberculosis lesion. And as I said, one can identify some of the microorganisms by performing staining, acid-fast staining of impression smears. And as you can see in this case, some microorganisms can be visualized, many more in this case. So this is of diagnostic significance. Another bacterial disease of chickens is referred to as infectious coryza, caused by Haemophilus paragallinarum, and namely responsible for respiratory disease or respiratory infection in chickens and pheasants. This is Haemophilus paragallinarum is a gram-negative rod, is highly pleomorphic, and is polar stained. It stains well on both ends. Most chickens affected are semi-adults or adults, and it has a predilection for the face of the bird. Now, once again, you diagnose it by culturing the bacteria from the exudates, and you will see in a couple of slides that some of the signs are in the form of exudates, and then demonstrating the presence of the pleomorphic bipolar organism in gram-negative stain smears. Now, this is one of the bacterial diseases that can actually be treated, although obviously what you want to do is you want to negate the microorganism and stop the introduction of the infection into your flock before you see clinical signs. Now, the drug of choice is a sulfa dimethacin. This is the preferred treatment, although there are other drugs that are just as effective as sulfa dimethacin, such as sulfamethacin, sulfamyricin, and erythromycin. Here you see a chicken with a swollen face, a swollen sinus actually, and this material is perfect for isolating the bacteria. The same in this case, and this swollen area here right under the left eye. The next bacterial disease I will quickly cover is fowl cholera, caused by Pastorella multocida. Once again, mainly seen in semi-mature and mature chickens, or actually mature poultry in general. The disease expresses itself in two forms: a chronic that mainly causes localized lesions, and an acute form that is so rapid because of the septicemia it causes that you may not see any clinical signs. The disease is transmitted mainly by carrier birds, once again like salmonella. We have the carriers. Wild birds may carry Pastorella multocida, and wild rodents as well. And as you will see from this slide, excuse me, about the one of the predilected sites of clinical lesions of signs is the wattle. This wattle is excessively enlarged. In this case, the oral cavity has been opened so that you can see the accumulation of caseous material that is typical of Pasteurella infection. And some of the lesions that are caused in the viscera are localized in this liver. And as you can see here, it sort of reminds you of what you may find with tuberculosis. So let's cover some of the viral diseases of economic significance for the poultry industry. And Newcastle disease is without doubt one of the most significant of them all. And as you can see here, I'm presenting you with a few viral particles typical of paramyxoviruses, Newcastle disease virus, as observed with the electron microscope. When very virulent Newcastle disease viruses affect susceptible chickens, the mortality could be as high as 100%, especially in the case of unvaccinated chickens. Now, this is a communicable disease, a disease that has to be reported. And as you can see, we have a tremendous export market that is at stake, around $2.8 billion a year. That the poultry industry in this country alone counts on. And this is a disease that we have to be aware of all the time because of this kind of catastrophic consequences should it be inadvertently or deliberately introduced into the country. The virus, it's paramyxoviridae, and mainly causes respiratory and nervous disease. For practical purposes, the viruses have been classified in velogenic, mesogenic, and lymphogenic to basically indicate a gradient virulence. Velogenic, the very virulent, mesogenic of intermediate virulence, and lymphogenic, which are basically the vaccine strains that we use to protect against velogenic strains. Here is a bird that is showing clinical signs of an affected nervous system, and typically seen when susceptible chickens are infected with a neurotropic velogenic Newcastle disease virus. The same thing could be observed here in another chicken. Sometimes they are referred to as stargazers, but what this is trying to tell you is that the central nervous system is affected. In other cases, when velogenic viscerotropic strains are involved, you will see areas of hemorrhages, profound hemorrhages and ulcers in the intestinal tract and the cecal tonsils here as well. And once again, in the intestinal wall, very profound hyperemia, hemorrhagic areas everywhere, and you see the spleen here as well, terribly hemorrhagic, petechia everywhere. The last outbreak in this country, in the poultry industry, occurred in 1971 in Southern California. As you can see from the slide, over 1,300 flocks were involved. They all had to be destroyed. And this amounted to 12 million birds. And over a 3-year period, the disease was finally eradicated at a cost of around $56 million. Of course, during this time, the prices for eggs and poultry in general were increased because of there were less products in the market. Now, as I said, this is a highly infectious and contagious virus. it runs through the flock fairly rapidly, as you see, 4 days, mainly by the respiratory route, as the excretions contaminate the environment, food, water, the environment in general. Now, it has been known that exotic birds, mainly citizen birds, are a source of very virulent, Newcastle disease viruses, and this disease is also reportable. Citizen birds are imported into this country, but through USDA quarantine. And it's only through after birds have undergone quarantine and proven to be free of Newcastle disease virus that they can be brought into the U.S. Now, this is not the common situation, but eggs may contain virulent virus. Fortunately, the virus kills the embryo, so these embryos never hatch. However, should the eggs be broken at the hatchery, then they would be a source of infection for the rest of the eggs, and the entire hatch becomes exposed. Now, in the laboratory, we have devised rapid ways of determining whether an isolated Newcastle disease virus is potentially virulent or non-virulent. In other words, is velogenic or perhaps meso or lentogenic. And we do this by doing molecular studies at the level of the cleavage site of the fusion protein gene. And it is believed that there's actually consensus that if around the cleavage site you have a pair of basic amino acids, like in this case arginine and lysine, and another arginine here, then you're probably dealing with a very virulent virus, as opposed to something which is lentogenic, a vaccine strain, where you only have one basic amino acid, in this case arginine, something like lysine, glutamine, and another arginine. So whenever you find pairs of amino acids around the cleavage site, that is considered to be indicative of virulence. We detect, what we do actually is we utilize a technique which is called reverse transcription, polymerase chain reaction with primers that amplify that area around the cleavage site, and then we sequence these products. And you see these are the products that were amplified, and then they are sequenced, and one determines whether one is dealing with a lento, meso, or very virulent velogenic strain. Fairly recent in the state of Florida, we were able to use this technique to diagnose Newcastle disease infection, or paramyxovirus was infection, because Newcastle disease virus is a paramyxovirus 1, in Eurasian colored dogs. These are dogs that are not native to Florida. They probably originated in around the Caspian Sea in Eurasia, and they were brought, or they came to the Caribbean, from the Caribbean islands, and from there they managed to introduce themselves, perhaps, or were introduced into continental U.S. And we've been able to detect outbreaks of Newcastle disease virus in Eurasian dogs in places like the Panhandle, very near the Everglades, in Monroe County, and also around in the St. Petersburg area in Pinellas County. So this is a very sensitive technique for diagnosing Newcastle disease, but you do need a certain molecular expertise in order to do that. Traditionally, the disease has been diagnosed by looking at the history, the clinical signs, and the lesions that one finds when forming necropsies. Mainly respiratory secretions or ground up lung suspensions are inoculated into embryonated eggs, free of maternal antibodies to Newcastle disease, to see whether we have a Newcastle disease virus infection. And then, if the virus is present, then one would see embryo mortality. The embryo will die, the virus will kill the embryo, and then one would take the laboratory fluid and perform hemagglutination. Newcastle disease virus is responsible for the agglutination of chicken erythrocytes, chicken red blood cells. Now, there are other avian viruses that also agglutinate, such as avian influenza. So one would have to perform a specific hemagglutination inhibition with anti-serum to Newcastle disease virus and avian influenza virus in order to determine whether one is dealing with one infection or the other. But these serological techniques are fairly specific. You could also perform a virus neutralization test. The disease in this country is controlled by vaccination. Obviously, before you start vaccination, you have to exercise great care so that the virus is not introduced into your premises or into the poultry flocks through fall mites, through contaminated materials. And but once it gets to vaccination, we dispose of a series of lymphogenic or mildly virulent or attenuated strains, such as the B1 strain or the Lasota strain, and they can be administered both in the drinking water or it can be administered at the hatchery. The only care is that it has to be administered as a coarse spray so that the virus does not penetrate deep into the respiratory tract and gives rise to respiratory problems. Birds that are destined for reproduction purposes or for egg-laying purposes have to be revaccinated. And the best strategy is to vaccinate birds during the growing period with attenuated live vaccines, and perhaps 3 or 4 weeks before the onset of laying, revaccinate these birds with an oil emulsion inactivated or dead vaccine. That way, the antigen mass contained in the inactivated vaccine is gradually released, and there is persistence of antibodies mainly against the fusion and the hemagglutinin proteins of Newcastle disease virus. And these antibodies have passed to the progeny through the egg yolk, and are very important in protecting the progeny against Newcastle disease during the early days of life. Now, as I mentioned before, Newcastle disease is a reportable disease. If one suspects of Newcastle disease, one ought to report it to the state and federal agencies. The state within your own state and the federal agency, USDA, wherever you happen to be. So, what is the main purpose of vaccinating against Newcastle disease? Obviously, when you're dealing with growers, you want to protect them both locally and systemically against clinical signs or morbidity and against mortality due to Newcastle disease. And you do that through mainly live attenuated vaccines. You also, when you administer the vaccine locally, like in the spray, you also do that in order to prevent damage to the respiratory tract. Newcastle disease, when it replicates, it could produce a certain degree of immunodepression that would give an opportunity to secondary bacterial infections to flare up and spread in the flock. And as I said, a combination of live vaccines and the attenuated vaccine before the onset of progeny basically guarantees that when the progeny is hatched, they're going to have a fairly high and hopefully homogeneous titer or levels of antibodies against Newcastle disease virus. Now, the next viral disease that I'd like to cover is viral arthritis. This is caused by a reovirus. Reoviruses is mainly a disease of economic significance in broilers, meat-type chickens. The virus could cause a chronic infection, especially during the first few months of life. Because of the chronic infection, the virus is eliminated or shed in the feces in such a way that the whole environment becomes contaminated. During this time, hens pass the virus vertically through the egg into the chick, or to the chick, so that when the chick hatches, it's already infected with reovirus. And in that case, we are going to see problems very early in life, mainly associated with joints, bad joints. Now, the virus seems to infect or persist in the infected animal for a fairly long period of time, and this is why sometimes when it is not possible to eliminate the flock and bring in a new flock, and eliminate an infected flock and bring in a new clean flock, produces wait until the animals attain a certain age, when hopefully perhaps at least 90% of them have stopped eliminating or putting the virus in the egg, to obtain eggs for incubation and hatching chicks, because then the percentage of the number of chicks hatch infected is very, very reduced. I would say less than 10%. This is what you actually see a typical in typical reovirus infection of broilers. This broiler here has swollen joints, which are painful, and is reluctant to stand up. As you see, is basically sitting on his hocks. And as you will see in the next two slides, the hocks are fairly swollen. There is a tremendous amount of exudate due to viral destruction, viral replication, and tissue destruction. And you may see hemorrhages around the joints. And in extreme cases, the tendons, especially the gastrocnemius tendon, may rupture. How does one make a diagnosis? Very few diseases actually cause clinical signs like reovirus, although you ought to be aware that something like staphylococcus may cause something fairly similar. But it is possible to pick up viral antigen on synovial cells obtained from the affected joints, and then stain them by in the fluorescent antibody with specific antiserum, and you will see viral antigen in these cells. You could also do ELISAs, which is the enzyme-linked immunosorbent assay, so gel precipitation on serum from your flock, from birds in the flock, to see whether most or some of the poultry, some of the animals have antibodies against the virus. Now, virus isolation is a rather specialized exercise, but it can be isolated in cells such as chicken kidney cells, chicken embryo liver cells, and also in embryonated eggs. Here is a slide where you actually see the tremendous damage caused by reovirus in the hog joints. You see exudate, edema, hemorrhages. It is from these areas that virus can be isolated. In this case, in this extreme case, when the joint cavity is open, you see that the gastrocnemius tendon is actually broken. Other diseases against which you must, you ought to consider in order to make the differential diagnosis are cirrhosis, this is nutritional deficiency basically, and then colibacillosis, E. coli, and pasteurellosis. Sometimes they localize in the joints, and it's important to isolate the bacteria or the virus in order to make a proper diagnosis. As I said, if one vaccinates early in life with highly attenuated live vaccines, and then before the onset of laying, with an inactivated oil emulsion vaccine, then that should produce a boost in immunity in the hen, and also diminish drastically the vertical transmission of the virus from through the egg into the embryo. The next viral disease of chickens, and this is a case where infectious bronchitis, a coronavirus of chickens, it's exclusively a virus of chickens. It does not infect, or it does not affect any other species of bird. Now, reputedly, is the most contagious avian pathogen. Only chickens are affected, as I said, and the infection is acquired mainly through the respiratory route by the inhalation of virus-containing droplets, as birds sneeze, gasp, and eliminate the virus in droplets. Some of the clinical signs that you observe in birds infected with infectious bronchitis, you can see on the slide. Hopefully, I'll have a couple of slides also to illustrate the point. But it's mainly related to the respiratory disturbances, gasping, dyspnea. Mortality could vary a lot, but most of the time it fluctuates around 20 to 30%. Of course, it's much higher in young birds, and it's much lower in birds that are semi-adult, about 5 weeks of age. But the disease runs through the flock very rapidly, and the morbidity is considered to be about 100%. Every single chicken gets infected in 2 or 3 days. Now, there are strains that are nephrogenic. That means they have a tropism for the kidneys, for the urinary system, and in this case, the mortality that is observed could be much higher. Now, mortality, you will notice, or you will suspect infectious bronchitis in the laying flock very rapidly when you see that your egg production drops fairly rapidly in a matter of 1 or 2 weeks to about 50%. Of course, this is a disastrous episode, and infectious bronchitis, besides Newcastle disease, is one of the influenza, is one of the diseases, one of the infections that you ought to be considering. Now, infectious bronchitis does very peculiar things. Infectious bronchitis virus does very peculiar things to the egg. So some of the eggs that are laid are sort of rough, irregular in shape. When you open this egg, the white, the albumin of the egg is very watery, because the virus affects the reproductive tissue. It affects the ovaries, it affects the eggs, but it also affects the respiratory tissues, and that's why the name infectious bronchitis, where you see a variety of respiratory signs, encephalitis, sinusitis. As I mentioned before, in the case of nephrogenic strains, you will see mainly swollen kidneys. This is the case of a trachea of a chicken with extensive respiratory lesions, and you see the presence of plugs, caseous plugs, that are occluding basically the trachea of the animal, and this will cause suffocation and death. Now, the disease can be diagnosed or can be confirmed in the laboratory by isolating the virus in embryonated eggs. The problem with injecting embryonated eggs is that not all strains, or not all isolates, induce changes in the developing embryo on first passage, and the diagnosis then takes it could take 2 or 3 weeks. Of course, you need a quick diagnosis, and this is where clinical history are of the utmost importance, and a good necropsy to make sure that you consider infectious bronchitis as the likely cause of the outbreak. Now, infectious bronchitis does not hemagglutinate like Newcastle disease. So if you infect chicken embryos and then test the corolanthoid fluids, you will see, in the case of Newcastle disease virus infection, that the virus will agglutinate chicken red blood cells, while infectious bronchitis virus will not. So when the virus replicates in the chicken embryo and on first, second, or third passage, eventually it will cause stunting of embryos, as you see here. This is a normal embryo. 19 days of embryonation, in other words, around 9 days after infection. You see curling of the embryo, stunting of the embryo, curling of the toes here, compared to the normal embryo. And this is considered to be pathognomonic, in other words, fairly typical of infectious bronchitis infection. Now, there are several serotypes of infectious bronchitis virus and many subtypes. Unfortunately, this has become a bit of a problem, and one must know what serotypes and what subtypes one has in the geographical area that one is dealing with, because these subtypes must be incorporated into the vaccine. There is very little cross-protection sometimes, most of the times, as a matter of fact, between serotypes. So if you are vaccinating, if you have in the area, let's say, variants of the Arkansas type, and you're vaccinating only with Massachusetts strains, you are going to see clinical cases of infectious bronchitis because there will not be full protection across serotypes. In fact, many times there's very little cross-protection across serotypes. So it is absolutely important that one incorporates strains or serotypes that exist in the area in the vaccine. Now, most times, infectious bronchitis vaccine is administered together with a Newcastle disease. Please do not mix these two viruses and then vaccinate birds. A vaccine against infectious bronchitis, or a dual vaccine against infectious bronchitis and Newcastle disease, necessitates a special formulation that is actually attained at the production site by the vaccine manufacturers. So only applied bivalent vaccines when the bivalent vaccine is manufactured by the biological company. Do not attempt doing it yourself because it necessitates a good balance of both viruses in the vaccine. Now, this vaccine can be administered both in the drinking water. It's a way of doing it very massively, very rapidly, without, using a minimum amount of labor. And it can also be utilized as an aerosol sprayers. Just make sure that the aerosol, or the droplet that is being utilized is large and not small, so you don't get penetration of the viruses to the lower parts of the respiratory tract. Some of these vaccines, even though lymphogenic, have the capacity to induce a certain amount of disease, so you want to be aware of that all the time. Now, for infectious bronchitis, passive immunity, this is immunity in the form of neutralizing antibodies that the hen passes through the egg to the progeny. It is very important, and it is for this reason that vaccination programs exist through which hens destined to reproductive purposes or for egg-laying purposes are vaccinated 2 or 3 times during the growing period with live attenuated vaccines, and maybe 3 or 4 weeks before the onset of laying with an oil emulsion inactivated OTL vaccine to make sure that the antibody titers are way up high, so when the hens start laying eggs, those chicks are hatched with reasonable levels of antibody. Another viral disease of poultry of significant economic importance is referred to as infectious laryngotracheitis. Now, this is caused by herpes virus, and alpha herpes virus it is highly contagious, and it not only infects chickens, it also infects pheasants and peafowl. Now, the strains that your poultry flocks are going to be in contact with are going to vary in virulence. They're going to vary in pathogenicity. So the nature of the clinical signs, or the intensity of the clinical signs, is going to vary depending on what strains are involved. Most of the times, you will see infections in semi-adult birds, not in young birds, and the mortality could reach 20%. But when highly virulent strains are involved, this mortality could attain levels of almost 70%. Now, as a herpes virus, infectious laryngotracheitis will cause a latent state, a latent phase, and recrudescence of the infection, activation of the infection, and elimination of the virus, and reinfection of the flock. Infection is usually attained by the respiratory route. Now, live vaccines are, most of the times, they are not terribly attenuated, so they could undergo latency and eventually be reactivated. And if some of these viruses have been passed from vaccinated to susceptible chicken, they could pick up virulence on this back passage and cause outbreaks months later. Some of the lesions that you will see associated with infectious laryngotracheitis could be confused with some of those caused by infectious bronchitis virus or Newcastle disease virus, although the tendency for infectious laryngotracheitis virus is to produce hemorrhagic lesions in the respiratory tract, and especially in the trachea. You will also see that birds, in their anxiety to get rid of the excretions and secretions exuding from the nostrils, from the nose, from the nose, they will shake their heads, and you will see that some of the feathers are stained with blood. One outstanding feature of herpes virus infections is that very early in infection they cause intranuclear inclusion bodies, and this has diagnostic value. Now you see here, for instance, a trachea that has been exposed to indicate necrosis of the mucosa of the trachea because of the virus proliferation, virus replication, and sections of the trachea, as I said, when stained with hematoxylin and eosine, will reveal the presence of the presence of intranuclear inclusion bodies, as you see here, and here, and here, and here, and here, and this is characteristic of herpes viruses, and you could fairly well close your diagnosis with those microscopic lesions. So once again, the typical clinical signs for the diagnosis of laryngotracheitis. One could also make impression smears of, and this is especially so in the case of very early lesions, when the lesions haven't been around for days, they haven't attained the stage where you have too much necrotic tissue. So let's say during the first 24, 48 hours of infection, one can produce smears with the internal side, the mucosa of the trachea, being stain the glass slice, and look for a viral antigen utilizing a fluorescent antibody test with specific anti-serum to infectious laryngotracheitis virus, and using a fluorescent microscope you will see viral antigens. Now this virus is isolated in the chorioallantoic membrane of the embryonated egg, and it produces plaques in the chorioallantoic membrane, and as you see here, these plaques are most of the times hemorrhagic in nature, and they have diagnostic value. If one does sections of the plaques of the coronal membrane, one would also see internuclear inclusion bodies. Now, why do we vaccinate against infectious laryngotracheitis? First of all, this is a reportable disease. One should not vaccinate in areas where the disease has not been reported or it hasn't occurred before, because, as I mentioned before, herpes viruses, laryngotracheitis virus, as a good herpes virus, alpha herpes virus, will cause latency and recrudescence in the future, and you could have an outbreak months after vaccination if this virus has been bypassed and has picked up virulence. So mainly we vaccinate to prevent clinical signs, morbidity, also to protect the respiratory tract from clinical signs, protect the bird from mortality associated with infectious laryngotracheitis. Now, an acute outbreak of laryngo also causes severe drops in air production that have to be differentiated with drops caused by infectious bronchitis. Now, when one vaccinates against laryngo, you must vaccinate all the animals in the flock as quickly as possible. Don't vaccinate today one part of the flock, tomorrow the other part, and perhaps day after tomorrow the rest. Vaccinate everything the same day, because you want to avoid passing of the virus from vaccinated animals to unvaccinated susceptible chickens. Now, this is one of the few diseases where when you have an outbreak, you could actually speed or stop the outbreak using a vaccine, mainly administered by a natural route, like the cloaca, for instance. So you can use slightly attenuated vaccine in order to slow down an outbreak in the presence of an outbreak. Well, in the case of layers and breeders, the strategy is fairly for passing immunity to progeny. It's fairly similar to the one that I have described for infectious bronchitis and Newcastle disease, although, to be honest, humoral immunity in the case of herpes viruses, in the case of laryngotracheitis virus, is of limited significance during the early life of the newly hatched chick. Now, the next virus that I'd like to touch is avian influenza. And you may recall from over the last 3 or 4 years that avian influenza made the headlines all over the world due to the outbreak in chickens in Hong Kong that crossed the species barrier and went directly from chickens to humans and actually caused mortality. If I remember correctly, in 6 or 7 of the people that were infected or show clinical signs. So it's a virus that has the potential to produce mortality in humans, and we should be on the lookout for clinical signs or flocks that in which one suspects avian influenza, because it has become, or it is now, a reportable disease because of its potential to also infect humans. Needless to say, it's of tremendous importance for the poultry industry, and that was exemplified by the outbreak that we had in Pennsylvania a few years ago, 1983, 1984, where an epidemic that was caused by an avian influenza virus of H5N2 type caused tremendous mortality, and it cost around $70 million to eventually eradicate the infection from infected flocks. Now, the epidemic that we had in Hong Kong in 1997 was caused by a different influenza virus, avian influenza virus. It was referred to as H5N1. H refers to the hemagglutinin type, and the N refers to the neuraminidase type of the virus. And they are very useful because there are specialized laboratories in this country and in countries like the United Kingdom, where typing of the isolated virus is done by utilizing monoclonal antibodies that recognize various hemagglutinins and various neuraminidase proteins. Now, waterfall I consider to be the main reservoirs of influenza virus. Unfortunately, most of the time, waterfall do not show signs of disease or infection. They are mainly asymptomatic at the point where they could be shedding or eliminating virus in the feces. Now, as I mentioned it before, for Newcastle disease, for velogenic Newcastle disease virus, avian influenza is isolated with a certain frequency from exotic birds. Cetacean as well, but several species of exotic birds. But once the infection is on the flock, once animals' poultry are infected, the virus has no difficulty spreading very rapidly through the flock by the respiratory route. Once again, the virulence, the clinical signs that are going to be observed will depend on the virulence of the strain. In the case of, but this is an unpredictable trait, so one ought to be prepared. Some of these viruses also can pick up virulence very rapidly as they are passed from chicken to chicken in the flock. But for the strains of low pathogenicity, the respiratory signs are mainly, or the signs observed are mainly respiratory. And you will see coughing, sneezing, wheezing, swelling of the sinuses, and of course, when some of these signs will result in problems that will necessitate differential diagnosis from other infections such as infectious coryza, Newcastle disease, infectious bronchitis. Now, some of the highly pathogenic strains will cause very severe mortality, an excess of 90%, close to 100%. Avian influenza has the capacity to produce encephalitis in affected birds, and you will see from this section of brain that the brain tissue is highly congested. It's a low magnification, so we will not be able to see specifically the virus-associated changes, but you will see that this section is highly hyperemic and hemorrhagic. In this area, on this slide, also of avian influenza, you will see that a foci of hemorrhages localized in the provinciculus. The trachea of a bird affected with influenza is highly hemorrhagic, highly pathogenic strain, obviously. In this case, the profuse hemorrhage, as you see in this dark area at the bottom of the exposed trachea, and these cases or cheesy materials that basically obstruct the trachea, and I'm sure in most cases kill the bird. Once again, exudates in the trachea here, in a much more protracted case of influenza virus. Now, the virus on a routine basis is isolated in the allantoid cavity of embryonated eggs. And then it has to be followed by serotyping and pathotyping. As I mentioned before, utilizing monoclonal antibodies. Most of the times, the virus kills the embryo in 72 hours, and then one takes a sample of the allantoid fluid, performs agglutination. If it agglutinates, you still have to differentiate avian influenza from Newcastle disease, and this is why the specific monoclonal antibodies come into place. Now, one could also use bare serum in a flock, where one could bleed a number of chickens, let's say on the day of the outbreak, and perhaps 10 days or 2 weeks later, obtain another sample, and you see whether there is an increase in the titer of hemagglutinating inhibiting antibodies specifically for influenza virus, and that should close the diagnosis. Once again, we are in the phase of a reportable disease, and you must report it if you suspect it to your state or federal agricultural authorities. Another disease, this time an oncogenic disease, but also caused by a herpesvirus, different from infection by Enterococcus, is Marek's disease. This is a lymphoproliferative disease caused by a highly cell-associated herpesvirus that utilizes the feather follicle epithelium that is under the sheath of the feather, at the root of the feather, to replicate and fall into the environment in desquamated cells or dander that falls into the environment, contaminating the environment very heavily. Three serotypes are known or have been described for Marek's disease virus. Serotype 1 encompasses all the naturally oncogenic or virulent strains of Marek's disease, and also those strains that were initially virulent, not necessarily very virulent, but virulent, because there is a resistance or the CVI 988 strain that was not that virulent, but it was serotype 1, and now is used extensively in this country to protect against Marek's disease. But mostly naturally pathogenic strains of chicken origin are classified within serotype 1. Serotype 2 encompasses viruses of chicken origin as well, but they're naturally non-pathogenic. And serotype 3 are those viruses that have been isolated from turkeys that are non-pathogenic for chickens. And the classical one is the strain FC126 that was isolated by scientists from USDA in the early 1970s, and that was eventually used worldwide for the protection against Marek's disease. It was the first time that a cancer, a tumor, a lymphoid tumor, could be shown to be protectable utilizing a virus vaccine. The tumors induced by Marek's disease virus originate in T cells, cells that had its origin in the thymus. As I said before, dander or the soil is very infectious. It serves as a source of infection to vaccinated chickens through the respiratory route. Now, in the case of Marek's disease, there has been described genetic resistance and genetic susceptibility, not to infection, but to the development of tumors. Poultry breeders have been preoccupied with introducing genes for genetic resistance into their germ lines, so that the poultry available for commercial purposes are not entirely susceptible to Marek's disease tumor development. There is also such a thing as age-related resistance to tumors, although this is observed mostly experimentally, because we do have in Marek's disease something which is called late breaks or late Marek's, and this is when chickens that are already producing eggs break down with Marek's, and one doesn't understand why this happens. Now, I will bring lymphoid viruses later, but the target tissue and the target cell for Marek's disease virus is the T cell, the thymus-derived cell. Marek's virus does not cause intrafollicular tumors in the birth cell fibrissions, the same way that lymphoid viruses do. Most outbreaks of Marek's occur in young chickens, chickens before, up to the age where they start laying, although there are cases where you would see late Marek's, but you will not see intrafollicular tumors in Marek's disease. Several types of Marek's disease have been recognized over the years: neural, ocular, cutaneous, and visceral. This is a case of a chicken that is showing a neurological disorder. You see one of the legs is sort of pointing backwards because most likely in this case the peripheral nerves were affected. Excuse me. In the case of a neural merix, you could see a unilateral involvement of nerves. In this case, this sciatic plexus here is swollen. It's swollen because it's being infiltrated by lymphoid cells of various types: plasma cells, small lymphocytes, large lymphocytes, lymphoblasts, plasma cells, as I said. And in this bundle, you see that the top nerve, it's changed. Its color is almost grayish and swollen. And when one does histopathology, sections of the affected nerve, one sees that the nerve tissue is infiltrated by cells of the lymphoid lineage. In fact, you will find here plasma cells, lots of edema, as exemplified by these clear areas, and small lymphocytes as well. Okay, this type of lesion is generally known as type B lesion. This is a type A lesion, much more intense, much more severe, but which is it's a lymphoproliferative response. It doesn't actually look as a neoplastic as the previous one, but it is obviously wrong, because you do not normally find lymphoid tissue or nerve tissue, the nerve, infiltrated by such a tremendous amount of lymphoid cells. Now, in the case of the ocular form, and in this case, you will see one eye. The one on the left here is the eye of a normal chicken, and then on the right, you see that the iris of the eye has been infiltrated, given its white appearance, has been infiltrated by lymphoid cells, so cells of the lymphoid lineage, mainly thymus-derived lymphocytes. So this is the ocular form. Other times you see, especially the moment of processing carcasses in the slaughterhouse, you see tumors, or cutaneous tumors of the skin, and these tumors are localized in the feather follicle, which is the feather follicle epithelium, which is the area or the point where one could isolate infectious virus. In fact, is the only area, the only point in the chicken body where one can isolate infectious virus. And this is the virus that drops with thunder and desquamated cells and contaminates the environment. In the case of visceral merix, you see here an infiltrate of a lymphoid tumor. This is known as a visceral merix. And once again, in the bursa fabricius, the normal bursa here, and there's a lesion here. This is very rare. You will not find this with frequency at all. But when one does histopathology of a lesion of this nature, you see that the infiltration is not intrafollicular, it's not inside the bursal follicle, but interfollicular. In other words, in the septa that separates follicles. There is no vertical transmission of Merix disease virus from the hen to the progeny. This is one main feature that differentiates Merix disease from lympholicosis viruses. Most chickens are now vaccinated either at the moment of hatching and one day old in the hatchery, or they're vaccinated when the embryo is 18 days of embryonation. And the general idea is to vaccinate the chickens with with serotype 3 virus, or a combination of serotype 3 and serotype 2, or perhaps with all three serotypes, before they get exposed to a contaminated environment. In other words, one wants to give the vaccine virus an advantage over the virus that the chickens are going to encounter on the premises on the first few days of life. Okay, you do not protect against infection. The purpose of vaccination is to protect against the development of tumors, because even though chickens have been vaccinated at 1 day of age or in the egg at 18 days of embryonation, they will still be infected with virulent Mary's disease. But somehow, for mechanisms that we still don't understand completely, chickens do not develop tumor. In other words, they can harbor both the vaccine virus and the oncogenic, the virulent virus, and will not come down with tumors. Properly vaccinated chickens are usually protected for life, in such a way that if one vaccinates chickens uniformly and properly post-hatching, there shouldn't be a need to revaccinate those chickens. However, and unfortunately, variants of Mary's disease virus have appeared over the last few years, and we refer to these variants as virulent variants or very virulent variants, and these variants do cause Mary's disease even in chickens that have been vaccinated, especially in chickens that have been vaccinated only with the herpes virus of turkeys, but also in chickens that have been vaccinated with a mixture of serotype 1 and serotype 2 viruses, serotype 3 and serotype 2 viruses. And this is where the live attenuated serotype 1 virus come into effect, because they seem to be to have a better protective ability against variants than serotypes 2 and 3 combined. So why do we vaccinate against Mary's disease? Obviously, we want to protect the laying or the breeder hen during its growing period, so that it grows healthy. Mary's disease virus has the capacity to induce immunosuppression, and by doing so, it will make the chicken susceptible to other pathogens, more susceptible to other pathogens, or to saprophytic bacteria, and it will also make the chicken more prone to perhaps develop diseases against which the chicken has already been vaccinated, because vaccination will not be that effective because of the immunosuppression. Now, in broilers, in meat-type chickens, obviously what we want to do is we want to protect that rapidly growing broiler from the development of tumors, so that when you get to the slaughterhouse, there are no lesions or tumors that would cause condemnation of the carcass. So I have already said that the chickens are vaccinated at embryonation 18 days or at 1 day of age. Serotype 2 vaccines are not usually used by themselves. They have to be combined with serotype 3 or with serotype 3 and 1 vaccine. So do not vaccinate chickens with serotype 2 vaccines only. You will have Mary's disease in the flock. And please do be careful when you're trying to add vitamins and antibiotics to the vaccine, because you could decrease or you will decrease the potency of the virus, because the virus is highly cell-associated. If you disturb or change the environment in which these cells that contain the vaccine virus are suspended, the cells will die, and then your vaccine virus will die with it, and you will not be very effective in inducing protection. Now, how does one choose the proper vaccine for vaccinating broilers? There are several rules of thumb, basically. So when your condemnations are low, for instance, you know this because you've been operating in this geographical area or this chicken farm, and if you know the condemnations are low, there's really no reason to use the bivalent vaccine. You could just use HVT, and that should protect fairly well against Mary's disease. When there is immunosuppression, you also want to use HVT, because some of the serotype 2 or 1 viruses, even though attenuated, could induce a certain degree of immunosuppression. Also, when the litter in your chicken houses is new, then the early exposure to virulent virus is basically negligible or non-existent. So you can use HVT. There's no need for use more aggressive Mary's vaccines. This is the machine that is being used to vaccinate eggs at the hatchery. you can vaccinate hundreds of eggs at a time. In this case, I believe they're vaccinating 100 eggs at a time. And what it is there is this mechanism that has a needle that is connected to the common reservoir of vaccine, and rapidly and efficiently introduces the vaccine into the alveolar cavity of the embryonated egg. The next disease I like to cover is avian lympholycosis, or LL as it is usually referred to. Now, this disease is caused by a retrovirus. This is different from Mary's disease, and is caused by a herpes virus. And the target cell or organ of lympholycosis viruses is invariably the lymphoid cell in the bursa of Fabricius. So it is known to have or to be of B cell origin. This disease is usually seen in mature chickens older than 16 weeks of age. That's when you see the clinical signs, that's when you see the tumors. And for all practical purposes, for many years, 4 subgroups of exogenous, which exogenous are the lympholycosis viruses that are known to induce tumors, have been known, subgroups A, B, C, and D. In these countries, viruses subgroup A and B. Mainly subgroup A were responsible, and are still responsible to a lesser degree, for mortality due to tumor development. In the last few years, a new subgroup, referred to as subgroup J, has appeared, and it's given rise to something which is called leukosis J, and it is believed that this new virus is appeared because of a recombination between endogenous viruses that are produced by chickens of many lineages, many lines, and exogenous viruses that have infected chickens. So over the years, this recombination phenomenon seems to have given rise to leukosis viruses subgroup J. So the most important mechanism of transmission is vertical through the egg, and viremic hens. Hens that actually were hatched as chickens and were viremic are the ones that perpetuate the infection from generation to generation in such a way that when a chick hatches from a viremic hen, it's said to be tolerant because it already has leukosis viruses circulating in its organism, in its body. And however, that doesn't stop the virus from spreading horizontally, especially during the first days of life in the hatchery, and also when they're put in the chicken house. You see here avian leukosis viruses in the white of the egg, in the oviduct of the egg. This is all white, but in the oviduct of the egg, as observed with the electron microscope. A section of a bursa Fabricius, possibly at around 8 weeks after infection with exogenous lympholycosis viruses, and you see that the normal bursal follicles are usually very small, and you have this large bursal follicle that has already been transformed by lympholycosis virus, and this is very large. But this is a microscopic tumor before metastasis or spreading of cancerous cells to the rest of the body. A bursa Fabricius of a bird that has a tumor, you see the septum that divides here the bursal follicle, and you see the cells here with a neoplastic characteristic. There are cells that were already transformed by lympholycosis viruses. Once again, a macroscopic tumor, but small, in the bursa Fabricius, in this area here, around 10, 11 weeks after infection. Now, the virus could cause nodular tumors. You see nodules all over the liver here, the spleen here, nodular tumors. It may cause diffuse tumors, where there is hardly any break in the tumor. The whole tissue actually becomes a single tumor tissue. The liver here, the kidneys are also affected, bone marrow. There's a couple of localized tumors here in the spleen. And this is what is called a miliary tumor, which is reminiscent of some of the tuberculous lesions that I showed you earlier in the talk, caused by Mycobacterium avium. And then liver tissue here, histopathology of lympholicosis caused by leukoleucosis virus in the liver of some of these large neoplastic cells. Now, in the case of leukosis, lympholeukosis, the cancer cell, the tumor cell, is fairly homogeneous. It's just a large lymphoblast. So when you're looking at a section, most of the cells look pretty much alike. And for instance, we do have here a renal tubule, and then surrounded by blast cells. These are metastatic cells. So as I said before, the flock, when affected, is fairly mature, greater than 16 weeks old. There is no nerve involvement in lympholicosis, and this is where you have a chance, an opportunity to differentiate lympholicosis from Marek's disease that causes infiltration of the nerves with lymphoid cells. You do not see infiltration of nerve cells with lympholicosis viruses. One can isolate the virus from tumor cells, but it has no diagnostic significance because lympholicosis viruses are ubiquitous in nature, and one could isolate the virus from cells that show no tumors. Now, over the past 25 years, breeders have been concerned with eradicating exogenous leukosis viruses from their genetic stocks, and they've done this by testing unincubated, non-incubated eggs, mainly the albumin of the egg, for what is called as the group-specific antigen of exogenous lympholicosis viruses, and all those hens that produce eggs that contain the viruses were eliminated from the stock, and eggs were only obtained from hens whose eggs were negative for the GS antigen, or the group-specific antigen. Over the years, repeating this operation over and over, they have managed to eradicate exogenous leukosis viruses from the breeder flocks. And very rapidly, as I said before, over the last few years, leukosis J, caused by subgroup J leukosis viruses, have appeared as a consequence of recombination of exogenous and endogenous sequences, endogenous viruses. Now, typically, this virus causes myelocytomas or myeloblastomas. You will see this with a higher incidence. Now, leukosis viruses of subgroup A and B also have the potential for inducing myelocytomas or myeloblastomas, but this is a rare occurrence. In the case of leukosis J, you will see with much more frequency tumors localized, once again liver, marrow, fat bones, spleen, and kidneys, and this is the same localization of lympholicosis tumors produced by A and B viruses. However, leukosis J you usually see in heavy breeds, and you will also see it in much younger birds. Now, it has acquired tremendous economic importance. As you can see here, it is reckoned that over the last few years, the losses caused by infection and by tumors induced by leukosis J viruses range around $90 million a year. Another disease that is of tremendous importance for the poultry industry is infectious bursal disease. This is a virus. It's important because it produces immunosuppression. It destroys the B lymphocytes or the precursors of the B cells that are localized in the bursal fabricius and produces immunosuppression. This makes chickens much more susceptible to pathogens that are not usually pathogens for normal chickens when the immune system is intact. And also, it doesn't allow vaccination to operate or to induce an effective as immunity as it would had the chickens not been infected with infectious bursal disease. Now you see, there's two forms, the clinical and the subclinical, and this is probably the most important form, the subclinical form, because it affects chickens very early in life, and you don't see the signs, but it makes the chickens highly prone to other infections. Not necessarily a very good slide, unfortunately. This is at the top here, the normal bursa fabricius was cut off when preparing the slide, so you only see maybe 1/3 of it. But if you could imagine that the bursa continues up here and is much larger than this affected bursa affected by infectious bursal disease virus. And this is the typical picture of a bursa of fabricius that's been affected by infectious bursal disease virus. There's a tremendous amount of edema. Unfortunately, not a very good slide, but you see that there is a rarefication of the follicles. They are being depopulated by cell death of the resident lymphoid cells, and this is possibly more clear in the next slide, where the disease has been allowed to continue for a few more days, and there's a tremendous amount of edema, depopulation of lymphoid follicles, and this leads to immunosuppression. So during the early stage of infectious bursal disease, you will see a swelling of the bursa, but very rapidly the swelling will translate itself into atrophy, and the bursa will almost entirely, well, at least the stroma of the parenchyma of the bursa fabricius will disappear, and will just leave the connective tissue around. Now, very virulent strains, when the strains are very hot, very virulent, you do not necessarily see the swelling or the hemorrhage or this edema of the bursa fabricius. It happens all very rapidly, and by the time you open or you necropsy the birds, you see that the bursas are very, very atrophied. You can diagnose infectious bursal disease by looking at the bursa fabricius and showing that they're very, very shrunk. You also look at the microscopic lesions in the bursa. You can reproduce the disease by injecting, this is not very practical, but if you prepare a macerate, or you grind up the bursa fabricius and deposit a drop of that cell tissue suspension into an SPF chicken, you will see that the inoculum, or the virus contained in the inoculum, will induce a very rapid regression of the bursa fabricius of the SPF bird in 4 or 5 birds. And then with the advent of molecular biology, we can actually diagnose Gumboro, as is also known, or infectious bursal disease, by utilizing the reverse transcription polymerase chain reaction on total RNA extracted from the bursa fabricius, and then performing an RT-PCR and showing that there are sequences of the virus present in the bird. Now, it's interesting that it's been worked out that the half-life of the antibodies, the maternal antibodies that are transmitted from the hen to the progeny, seem to be different for layers as for broilers. As you can see here, the half-life of maternal antibodies in layers is around 6 or 7 days. In other words, they seem to last just a bit longer than the maternal antibodies that one sees in broiler or meat-type chickens, where the half-life is only 3 to 4 days. So these are concepts that I think have to be taken into consideration when you are vaccinated against Gumboro, infectious bursal disease, young chicks. You want to vaccinate your broilers possibly earlier than your layers. Quickly, a successful vaccination, I have covered several infectious diseases, bacterial and viral, And what is the bottom line? I think the bottom line at the poultry house or the hatchery or in the field is that one ought to use fresh vaccines. Do not use vaccines that have already expired. Do not change the administration routes of the vaccine. In other words, if the vaccine is recommended to be for administration in the drinking water, do not use it as a spray. Bear in mind that when you buy Newcastle disease infectious bronchitis vaccines, they have been specially formulated at the manufacturing site so that there is more of one virus and less of the other. So do not mix vaccines for Newcastle disease and vaccines against infectious bronchitis and administer that to chickens. Now, even though these dual vaccines against Newcastle disease and infectious bronchitis are formulated in the laboratory, they do not protect as well or for such extended period of time as vaccines that are formulated for individual viruses. As I said before, in the case of laryngotracheitis, do not introduce the vaccine in areas where the disease has not been reported previously, because you will be introducing potentially a source of infection many months to come. Well, I have run very, very rapidly through some of the most interesting or economically most important avian diseases, avian pathogens. Many have been left out. The poultry industry is without doubt the most rapidly. It's a very competitive industry to begin with. It's highly integrated vertically. It fulfills a whole circle because it not only produces chickens, it's integrated to the feed industries. It produces breeders and layers, and then back to the slaughterhouse. And it's highly technified. There is no single other animal industry that is as technified as the poultry industry. The costs for production are very high. For instance, when it comes to nutrition, it is calculated at 70% of the cost of producing a chick is feed. So if you do not vaccinate chickens properly against some of the avian pathogens I have exposed you to, you're basically risking 70% of your investment already that went in the form of feed by not immunizing a flock properly against some of the potential pathogens that are just waiting to be introduced in a poultry house. Well, I expect that when it comes to our session, our questions and answers session, I might be able to clarify perhaps some of the issues through which I had to run very rapidly in order to cover as much as I have covered, and that way I will have the opportunity to clarify some of those issues, or perhaps add to what I have already reported today. I thank you for your attention, and I will see you soon.